In this lesson, we will prove the commutative property of multiplication by using arrays and area models. In second grade, students learned to make rectangular arrays and write addition equations to find the sums. For example, they would use 6 squares and arrange them in a rectangle. This would show that they have 2 rows of 3 squares. They would write this addition equation as 3 plus 3 equals 6. Addition is fine, but multiplication is repeated addition and is usually faster. First of all, remember that an array is a rectangular arrangement of items. It has rows and columns. For instance, this is an array. This is not. It's not rectangular. Rows run from side to side, and columns run from top to bottom. Let's say that we've been asked to set up 10 chairs for a meeting. We've been asked to arrange them in equal rows and columns. What are the different ways we could arrange the chairs? Well, if we have 10 chairs, we could line them all up in a row. That's one option. Depending on the room, we might go the other direction. As long as they're in a rectangular arrangement, we have a proper array of 10. Another option would be to have 2 rows of 10 chairs. 2 rows of 5 chairs. Still a rectangle. This is still an array. Again, we could turn it the other direction and have 2 columns or 5 rows of 2 chairs. All of these arrangements have 10 chairs. All right, so far, if we wrote these as multiplication problems, we have 1 row of 10 squares or chairs. We had 10 rows of 1 chair. We had 2 rows of 5 chairs in each, and we had 5 rows of 2 chairs in each. This is how we write the multiplication equation. In each case, the answer was 10. We had 10 chairs, no matter how we arranged them. The commutative property of multiplication says that we can multiply numbers in any order we like and still end up with the same product. We've just shown that this is true with our chair arrangements. We can arrange them several different ways and still have 10 chairs. Similarly, we can multiply our numbers in a different order and still have the same product of 10. We can multiply 2 times 5 or 5 times 2 and still have 10 chairs. If we take our squares and squish them all together, we still have an array. Let's squish them together. It's still rectangular and it's still an array, but this time we call it an area model. An area model is just a special kind of array to help us find the area of a shape. For instance, if we're given 12 squares and told to arrange the squares in a rectangle, we can do that several different ways. We could do it as a 1 by 12 rectangle or a 12 by 1 rectangle. We could do a 2 by 6 rectangle, which is also the same as a 6 by 2 rectangle. Or we could do a 3 by 4 rectangle. This is also a 4 by 3 rectangle. It just depends on which direction you're looking. In any case, we know that these arrays all have an area of 12 square units. We still have 12 of our squares. If we were given the dimensions of an array, we could find the area of that array as well. For instance, if we were told that a room we wanted to carpet is 4 feet by 6 feet, we could make an area model to represent that and then calculate the area. To find the area of this array, we could multiply or we could count the squares. You could count them 1 by 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so on. Or you could use multiplication. Since we're in 3rd grade, we want to do multiplication. This equation would look like 4 times 6 equals 24. If we had arranged it the other way, it would be 6 times 4, which also equals 24. Finding the area of a rectangle using the area model will be discussed in more detail in the measurement and data domain. If you'd like to help your student practice this concept, there's a simple activity you can have them do. Give your student a piece of graph paper and a 6-sided die. Use 2 as one of the factors. This will not change. Have the student roll the die. If the student rolls a 3, then have them draw an area model on the graph paper to show a 2x3 array. Also have them write the multiplication equation for the area model and calculate the area. So they would roll a 3 and draw a 2x3 area on their graph paper. Say the next time they rolled a 6. They would draw a 2x6 area on their graph paper. Have them keep doing this until their graph paper is completely full of arrays. To review, we can arrange items in a rectangular array and write a multiplication equation to represent the array. We can have similar arrays, like 2 times 5 and 5 times 2, that have the same number of squares. This shows us that we can multiply the factors in any order and still end up with the same product. In this lesson, we proved the commutative property of multiplication by using arrays and area models.